Hello, it is a question related to inverse Fourier transform. We have to find out the inverse Fourier transform of rectangular pulse shown in figure. So this is a rectangular pulse shown in figure, and we have to find out its inverse Fourier transform. So we know inverse Fourier transform of we know if xt is time domain signal, if xt is time domain signal and x omega is frequency domain signal, then the relation between time domain and frequency domain signal is means inverse Fourier transform relation between time domain and frequency domain signal is xt is equal to 1 upon 2 pi integration minus infinitive to infinitive x omega multiplied by e की power j omega t d omega. This is the relation between time domain and frequency domain signal, and here frequency domain spectrum is shown and we have to find its corresponding time domain spectrum. So this may be written as 1 upon 2 pi, because signal exists from minus omega to omega on frequency axis, minus omega to omega. So we can change the limit from minus omega to omega, and here value amplitude of the signal is 1 in the range of minus omega to omega. So in place of x omega we may write 1 e to the power 1 multiplied by e to the power j omega t d omega. So this may be written as 1 upon 2 pi limit omega to minus omega e to the power j omega t d omega. Now we know integration of e to the power mt dt is equal to e to the power m divided by m plus c. So using this formula, given integration may be written as xt is equal to means inverse Fourier transform of given signal will be 1 upon xt is equal to 1 upon 2 pi e to the power j omega t, because we are differentiating it with respect to omega. So it will be e to the power j omega t divided by e to the power j omega t divided by j t, and this is the limit infinitive to minus infinitive. So this may be written as 1 upon 2 pi. So this may be written as 1 upon 2 pi multiplied by jt e to the power j omega t. Here it will be, sorry, limit is omega to minus omega. So it will be e to the power j omega t minus e to the power minus j omega t. So this may be written as this may be written as 1 upon pi t multiplied by e to the power j omega t minus e to the power minus j omega t divided by 2j. Now we know sin x is equal to e to the power jx minus e to the power minus jx divided by 2j. According to this formula, e to the power j omega t minus e to the power minus j omega t divided by 2j, because sin x is equal to e to the power jx minus e to the power minus jx divided by 2j. So according to this formula, this may be written as xt is equal to 1 upon 2 pi multiplied by e to the power sin omega t. This may be written as pi t multiplied by sin omega t, multiplied by sin omega t. So xt may be written as, we may rearrange some things. So this may be written as sin omega t. Here we are multiplying it and dividing it by pi, omega t multiplied by pi divided by pi t and here we may here pi t we are multiplying and dividing by pi, okay, and again omega, and here we are also multiplying and dividing by omega. Now again this may be rearranged. Here this is same, sin omega t is multiplied by pi and divided by pi, and pi t is multiplied by pi and divided by pi, and in numerator and denominator omega. So this may be written as omega divided by pi, omega divided by pi multiplied by sin pi multiplied by omega t divided by pi, omega divided by pi, and here it may be written as omega, and so omega divided by pi sin omega t multiplied by pi divided by pi, and here it may be written as omega t multiplied by pi divided by pi, omega t multiplied by pi. Now we know sin pi x divided by pi x is equal to sinc function, sinc function, sinc x. Sinc of x is defined as sinc of x is defined as sin pi x divided by pi x. So this may be written as xt is equal to omega divided by pi. This may be written as sinc, because sin pi x divided by pi x. So this may be written as sin pi x divided by sin pi x divided by, so this may be written as sinc omega t divided by pi. This is equation 1. Clearly its amplitude, clearly this is a sine function and its amplitude will be 0 when omega t will be integral multiple of pi, because xt is equal to sin omega t divided by pi t. So its amplitude will be, it will cross omega axis when omega t is integral multiple of pi. So is clearly this equation 1 will go to 0, at x is equal to, at t is equal to, from here it will be t is equal to pi by plus minus pi by omega plus minus 2 pi by omega and so on, and using L'Hospital rule its value of t is equal to 0 will be, limit t tends to 0, because this function is in the form of sin omega t upon pi t. It is in the form of sin omega t at t is equal to 0. Its value numerator will be 0, because sin 0 is 0 and denominator will be 0. So using L'Hospital rule, this may be written as limit t tends to 0 sin omega t divided by pi t may be written as limit t tends to 0. Differentiation of this will be omega cos omega t, and differentiation of this will be pi. So its value of t is equal to 0 will be omega divided by pi, and its graph will be like here. This is its graph. It will be like this. This is time domain signal, and it will cross. It clearly it will be a sinusoidal signal, and it will cross axis at, and it will be like this sinusoidal signal whose amplitude will decay with time, and it will cross omega axis at, omega axis is pi by omega, 2 pi by omega, 3 pi by omega on positive side, and at negative side it will be minus pi by omega, minus 2 pi by omega, and minus 3 pi by omega, and so on. Thank you.